Then, once we have in mind what we have to we have to structure the demand planning process, which are how to define the level of aggregation and how to measure performance of this process, we can deep dive a little bit on how to manage in practice the demand, in particular how to understand the characteristic of the demand. And this leads to the discussion about demand analysis. Demand analysis means analyzing and characterizing the aspects related to the demand that we have to manage. And we have seen that we can split this in two parts. One is understanding data characteristics through graphical representation and descriptive statistics. Once we have done that, we can identify components, characteristics of the demand. Let's start with graphical representation. So the first things you have to do when you have data is to give a visual representation of the data, of the demand. This can be done through simple graph, so by plotting timing and value of the demand, or with scatter plot, so by crossing value of the demand with value of other variable, like in this case revenues with employees. And this is important to understand fundamental characteristics, fundamental pattern, visual phenomena that can already be highlighted just looking at the demand look like. Second thing you have to do is to calculate some univariate statistics, so basic statistic related to the demand. In particular, we have seen mean, so the order of magnitude of the demand, so the average value of the demand, median, the value of the central observation, mode, the most frequent observation, and dispersion measure, like the range, max, less, minimum, the variance, so the spread of the value, considering the fact that higher different are accounted as having a higher impact because they are square, standard deviation, so the dispersion around the mean, and the coefficient of variation, so the ratio between the standard deviation and the average value. This is called univariate statistics. Univariate statistics is called like this because it is the first step of understanding statistics of the demand, as the second step is bivariate statistics. In particular, we have seen that bivariate statistics means getting if the demand is correlated with some other variable. In this case, you see two different types of demand, the blue coming from northwest and the red coming from northeast. As you can see, even if they are not the same, they have a similar trend, a similar pattern. So it means that these two demands are correlated. It is useful to understand if two demands are correlated or if a demand is correlated with other variable, because if the other variable is more manageable, focusing the attention of this one can be also useful to manage and to make forecast and to make prediction about the main demand that we want to analyze. If we don't want to calculate the correlation of the demand with other variable, a second option is to calculate what is called autocorrelation or lag correlation. The autocorrelation means understanding if the value of the demand are correlated with the value of the same demand in other period. Like for example, in this case, when the lag equals to 1, we are understanding if the demand in the second period is correlated with the demand in the first period by lagging, by creating a second series, which is the first one just postponed of one period. Demand in period 2 correlated with 1. Demand in period 3 correlated with period 2. Demand in period 4 correlated in period 3, and so on. We are understanding if this demand is correlated with this demand and vice versa. So if two following observations are correlated within each other. Here we have seen that the correlation coefficient is 0.82. There is some correlation which is not so strong, but some correlation exists. So it means that in our case, two following observations, two following values in two following periods have some points in common across the demand data set. This is another example. I can evaluate an autocorrelation with lag equals to 1. I can also evaluate the correlation with lag equals to 2, which means creating a new value of the demand, which is no other than the previous value of the demand just lagged of 2 periods. If I correlate this to demand, it means that I'm going to analyze if demand in period 3 is correlated with the demand in period 1, if the demand in period 4 is correlated with the demand in period 2, if the demand in period 5 is correlated with the demand in period 3. Generally speaking, if each value of the demand is correlated with the value of the same demand 2 periods after the current one. In this case, 0.72 means that there is no statistical significance in terms of correlation with lag 2. When you find a correlation like lag equals 4 or lag equals 6 and you find a strong correlation coefficient, this means that this is the cycle of the demand. So if you find that lag equals 7 is a strong correlation, gives you a strong correlation, means that each observation is correlated with the one after six period after this. So it means that the cycle of the demand, if these are months, is 6 months. So the demand repeats itself each after 6.
Now let's see how the concept of demand analysis apply to the San Pellegrino case. As we have seen, like this is the type of demand that we have to analyze, as we saw that this is the demand series that we have to analyze for then forecasting, which is the result of the aggregation, as we discussed, of these 5 different type of demand, which include 5 different type of orange juice beverage, which are all the same for what concern the type of packaging. Here you see the code, these are different type of beverage, but the code is the same. So this is our unit of analysis, this 90-50,000, which again is demand of 1,000 lots, where each lot has 12 cans in this case. So actually the real demand is this multiplied by 12 is what we have to analyze. The first step that we saw is demand analysis. So this is the series, and the first things that we do is to realize a graph, so to plot the data. To do that, again, you just highlight the data, you do insert, and Excel already recommend a chart that you can use to display the different data. And that's the result. So you can see that the trend is quite unstable. You see that there is a very discontinuity in data representation, which of course will give you some thoughts about it. But then you have to calculate the different statistics. So mean, mode, median, minimum value, maximum value, range, variance, standard deviation, and coefficient of variation. Again, mean, you have simply the function average. For the mode, which is the most recurrent value, you type mode. Median, you type the common median, so the value around which the series is centered. Minimum value, the function mean. Then you have max value, then you have the range, which is the difference between the minimum and the maximum and the minimum, the variance, the standard deviation, and the coefficient of variation, which is the ratio between the standard deviation and the mean. Remember that, don't be confused, standard deviation is called sigma square, while instead it's called sigma, while instead whenever you have sigma square, we're talking about the variance. Okay, The conclusion that we came upon this is that the series is centered around an average value of 1079 units, which are lots of 12 cans, but actually this is a very unstable demand, or like there is a lot of variability in the demand if you look at the other statistic, because again we have a standard deviation of 819, which is almost like equal to the mean, so it means that there is high variability, and a coefficient of variation of 76%. So you have a variability of 76% compared to the demand, and this is also represented by the value of the range, because again you have a very large span of value that goes from 0, so you have period where you have 0, and 3,922 lot of 12 cans. We can do a more detailed analysis of that. We have seen by plotting the different distribution of the value of the demand. Again, as I told you, how you define this interval is up to you, as far as you are aware of your choice. So there's not like a rule. Like the fact that I count the value that falls between 0 and 100,000 a lot, 101 and 200, 201 and 500. It's my rule. You can define it as I want. As I told you, in my view, lower value usually tends to be more discriminated, while instead higher value tends to be less, more aggregated. So that's why you see 0, 100, 100, 200, 200, 500, 500, 1000, then from 1000 I just go down 100 on 100, but on 500 on 500, but that's your rules. You can explain. What I may do is that defining this interval and then using the count if function, I'm telling Excel to count, okay, please, this is demand series, please count me the value of the demand which are lower than 100,000 cans, lot of 12 cans. Count me all the value that are lower than 200 but higher than 101, higher and equal than 101. Count me all the values that are lower than 500 and higher or equal than 201, and so on. So I know that here I have 104 values. These, of course, need to be 104, as you can see here. And you see how they are distributed. 10 falls within this interval, 5 here, 10 here, 37 here, 16 here, and so on. If you plot with a statistical graph, okay, so this is an histogram, so this is a vertical histogram, the frequency, you can see how these values are distributed, and as we discussed, this value, even if not super precise, they reflects a bell curve distribution, which is skew a little bit on the right, so there is a positive skewness, which means that your distribution is more variable toward the lower values, which is not a very huge problem, because again we are talking about the demand, so it means that your forecasting process will be focused in predicting the demand, giving values which magnitude will be around the mean. The higher risk is to give a value that are higher than the actual ones, because there is high probability that your actual values of the demand will be lower than the mean. This is a problem because you will be inefficient, you will produce, you will buy, you will distribute more than needed, but actually won't affect your ability to go into the market, because the probability of being higher than the average is low. And so actually you will produce, purchase and distribute more, but your ability to satisfy the market request, the customer request, won't be affected too much, which again, compared to our initial consideration, where we saw a lot of instability in the demand and a lot of criticalities for what concern the ability of understand and find pattern in the demand, this is a good finding, because again we are telling that not only there is a tendency to be distributed as a normal curve, but also that there is a skewness on the right, right? So even if a demand like this can be very problematic to be forecasted, when I do, the risk is more higher in over forecasting than in under forecasting, which means that in most of the cases I will have something more done, purchasing, production and distribution, while the actual demand will be distributed on lower value. So again, I will be inefficient, but not at risk to not satisfying the market demand. These are all the considerations that you are supposed to make when you analyze the univariate statistics. When we speak about instead the bivariate statistic, we have seen that we are interested in understanding if the demand in a period, okay, is correlated with the demand in another period, and we have seen that this is called lag. So what we have to do is to analyze the correlation between the demand and the demand lag of 1, 2, 3, 4, 5, 6, 7, until when? Until 52. Until 52. Why? Because 52 is the period that covers the unit of the total of frequency of recording of the demand. So demand is recorded in 1 year. How many times per year? 52. So it means that you can lag the demand according to how much it is recorded of 52 period. Okay, what you have to do practically in Excel is simply copying the series here. Okay, copying the whole series and pasting like lagging it in one period. Okay, so you copy it here and you paste it in of one period. Okay, what you have to do is then using the correlation function. Okay, look at here what happened. In this case, I'm analyzing a correlation of the demand within itself. So the correlation is 1. Here, I'm analyzing the correlation of the demand within itself and the demand lag one period. Pay attention to take just 104 values where the first are empty to highlight the fact that you are lagging the demand. Okay, so in this case, again, remember what we covered in theory. We are saying that we are analyzing if the demand in period 2 is correlated with the demand in period 1. Okay, if the demand in period 3 is correlated with the demand in period 2, 4, 3, 5, 4. Is it correlated? No, because we have a correlation coefficient on minus for 0.14, which is not significant. Here, what we are doing, we are analyzing if the demand in period 3 is correlated with the demand in period 1. If the demand in period 4 is correlated with the demand in period 2, and so on. Here, if the demand in period 4 is correlated with the demand in period 1, and so on. So that's the idea behind that. And you can see that if you do that for all the period, like the highest one is obtained. This one, the one that I changed in class. Okay, the highest one that we obtain is this one, which is not really like a significant value. So the highest one is this, so you can conclude eventually that if you want to give some evidence, or that there is no significant correlation with any period, if you see the values, there are not, besides the first one, which is 1, the other are not significant. The only very weak correlation if with the demand, you see that the demand in period 455, okay, is correlated with the demand 1 year before, 950, okay? So you're actually saying that demand from 1 year to the other in the same period may be very, 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 very weakly correlated, because remember that as threshold values in supply chain, we usually use 0.7 or 0.75. Below this threshold, negative or positive, usually affirming that there is correlation, especially for demand forecasting model, is very risky.